Your 9th and 10th grade review for area perimeter section. Get ready. All right, so you need to know your formulas. These are some basic ones that the ACT expects you to know. Sometimes they'll give you the trapezoid one. Sometimes they'll give you the regular polygon, but not usually. Or, diagonal with the rhombus. But, the less you have to go and, search for it, and you can just pull it back up in your memory, the better off you'll be. Of course, some of these have more than one. A regular polygon, of course, apothem times perimeter divided by 2. Make sure you're using perimeter and not just a side length. A kite, technically this could work for all your parallelograms. Parallelogram, rectangle, rhombus, square, diagonal times diagonal divided by 2 will give you your area of your shape. So, trapezoid, base plus base, those are the two parallel sides, times the height divided by 2. Make sure you add it first, then multiply by the height. A lot of people tend to leave that height off. Be careful with that. Of course, there's your Pythagorean theorem. Know that by heart. Of course, we use leg squared plus leg squared equals hypotenuse squared. But that's the generic, version of it there. Rectangle and parallelogram and a rhombus and a square. Basically, base times height. One side times the other. But make sure B and H, the base times height, base and height must meet at a right angle. If you're not looking for that right angle, you're not probably picking out the right pieces. Base must meet the height at a right angle. So if you don't see the right angle, you got to do something different. All right, and then of course there's the triangle. Same thing. The base and the height have to hit at the right angle. So don't just pick two random sides. And then your circle. And we haven't talked much about circles, but that's still pi times radius squared. That's something you've seen before. Be able to do this as a matching part of the test. Okay? Know your formulas. Make some flashcards. All right, so the first one is a kite. And so our kite formula, think back, was the diagonal times diagonal divided by 2. So diagonal 1, diagonal 2 divided by 2 will give you the area of a kite. And so that diagonal, that whole thing across there, you got 3 on this side, you'll have 3 over here, so that's 6 for the whole diagonal, times the up and down diagonal, 9 plus 15 gives you 24. And then set all that on top of 2, plug it in the calculator, and you get 72. And that would be meters, so square meters technically. No, I won't count off if you don't put that, but just know that's what it means. It's just a way of describing the area. We're not talking about the rim around it. We're talking about filling in the whole flat surface, covering the whole area inside of it with red. So square, inch, meters, whatever it would be. All right, next, find the shaded area. So this time you've got to do a couple different things. You have a figure on the outside, you have a figure on the inside. On the outside is a square, okay? A circle fits perfectly inside of a square. Unless you saw 2 circles, then it would be a rectangle. But we only have 1, so circle, and it's, equally spaced. I've seen it before where they had 4 of them, so that would still be a square because they would fit perfectly inside of there. That's not very great, but you get the idea. All right, so that's a square, and then minus your inside, which is, of course, your circle. So now put your formulas in. The square is base times height, side squared, however you want to do it, and then minus pi times radius squared for your circle. Now you've got your info for your circle. The radius is 8, okay? But you still got to get the sides of the square, and there's nothing out there. Well, that 8 is going to help you. 8 all the way across would be another 8 for your diameter, and so that whole diameter is now 16. Well, that is the whole way across right here as well, 16, and since it's a square, 16. So that'll be 16 squared, or 16 times 16, not times 2. 256 is what you get for that part, minus 201. Let's go back a second. The ACT would leave it as 64 pi right here, because this would give you 64 pi, and they'd stop, and that would be your answer. But we're going to put it in and really work it out. 256 minus 201.06. And so subtract, and you get 55.04. Don't round it to a whole number, okay? Just give me 1 or 2 decimal places. That way you won't be rounding off something crazy. Okay? It's better to give a little extra than cut it off too early. Alright, next, find the probability of hitting the shaded area. So this is actually number 6. So we're going to skip down there because it's like the other one, outside minus the inside. I got a rectangle on the outside, I got a rectangle on the inside. Base times height, base times height. Fill in your parts. This is how you get good at math, is do all the steps. So the base and the height on the outside, 25 times 18, and the base and the height on the inside, 16 times 10. So that gives me 450 on the outside minus 160 on the inside, and that leaves me 290. Now we've got to use 2 of these numbers, the outside and the final answer, the shaded. Because I'm saying, what is the probability? What's the chance if we throw the ball or something and we're going to hit the shaded instead of the white part? So we're going to set up a ratio, the part we want over the whole amount, or the shaded over the outside. My outside was the 450. My shaded part was the 290, that final answer. So these 2 numbers over here, we use and plug those in, and then put them in the calculator and divide it. Top always goes in first. When you have a fraction, it's always the top divided by the bottom. So 64.4, something close to that, percent. When you move the decimal over, remember you got to move it to make a percentage. So 2 places back. That's a chance of hitting the shaded part, big shaded part. All right. All right, going back to number 3. I'm looking for a quick expression for perimeter. Okay, looking perimeter. What do you normally do? Add up all the sides. Well, this side should be 12x. This side should be 5x minus 8. These are rectangles. It says rectangular fence. So this is like an ACT problem. They'll make you read a bunch of junk about it, but then they just want you to set up the perimeter. Write an expression. So you're not going to get one number answer. You're just going to put all this together. How many x's? 5x, 5x, 12x, 12x. That's 34 x's. And then get my regular numbers together. -8, -8, that's -16. So this is my expression, simplified expression for that perimeter. Okay, that's all they asked for, so stop. All right, and then number 4, you're going to look at a perimeter of a parallelogram. So if you need to draw it out. Perimeter is what we're looking for. The perimeter is already 26 inches. So this is like the ones we did in class where they had it in the middle. And one side measures 10 inches. What's the other side's going to have to be? So you can put the 10 on top side, doesn't matter where you put it. We do know one side, if this is a parallelogram, the opposite side matches. So what we're now missing is the top and the bottom, and they match. So you could put the same variable. So now let's set it up like we did in class. We got 2 x's, we got 10 and 10, that's 20, equals a total of 26. So subtract your 20, 2x equals 6, so each x is 3. So my sides, and it'll be listed like a multiple choice, my sides I needed. I got an extra 10, I got a 3, and a 3. That's how your answer will be set up on the test. Like what were the remaining sides, 10, 3, and 3, when I gave you one side to begin with. Alright, find the perimeter of the trapezoid below. Now this one looks terrible because it's so big, but it's really not that bad of, figuring out, and you do have to do a little bit of counting. First, let's count from the origin straight over here. You don't even have to count. Look, it's almost 6, so that's 6 spaces. From the origin back, that's another 6. So how long is this whole total bottom? That's 12. So the bottom piece is 12 all the way across. Same thing on top, it's coming out to 4, and then 4 going that way. So that's 8 on top. So we got 8 plus 12 so far. Now we got to figure out these slanted pieces, and let me clean it up here. We're going to have to cut it. When it's slanted, you can't just count it like we were just doing. You're going to come down and cut that edge right there, and what you end up with is our good old familiar right triangle. And so that's 1, 2 spaces. So put a 2, 1, 2, 3, 4, 5, 6, 7 spaces up. So 7. So Pythagorean theorem, 2 squared plus 7 squared will give us that hypotenuse squared. All right. So that's not a height, that's a hypotenuse. When you work this out, it ends up being 7.3. And you want to make sure they both match. Check over here. This was 2 going across, and this is 7. So yeah, that's going to match it. Same numbers. So when we think back, the whole thing, I got 7.3 for the slant, 7.3 for the slant. This was 8 up here and 12 on the bottom. Perimeter, and it's been sort of rounded off there. So add them all up, and you get 34.6. Okay. And that would be whatever units, didn't say, so units, that'd be perimeter. Now, if you were asked to find the area, same problem. You don't have that much more to do, but you got to think about your formula. Base plus base times the height all over 2. My two bases are 8 and 12, okay? Times the height, that was the straight up and down height that we had here earlier, and that was 7. So times 7 all over 2. And so now, put this in the calculator first. 8 plus 12, that's 20 times 7 divided by 2 gives you 70 for the area. So that'd be square units. This was area down here. All right, we might have either one on the test, so be careful. Wait for it. All right, then our trickiest one out of all of them. We want to find the area of this slanted triangle. You don't have any of the sides lined up, so you can't just count to see a side. Base times height won't work on this. What you will have to do is think about what we did in class and say, okay, I'm going to do the rise and the run for each side from A to T, my rise and my run. And then from T to V, rise and run and rise. And then over here, and I'm going to do it on the outside, on the rise and run, like that. So it's going from A to B, but it's kind of going backwards. That's still the rise, that's still the run. We're not worried about direction or anything, but we want this square around the outside. So that whole big square has a bottom length of 7 and a height of 8. So we're going to have the square on the whole thing. That's like saying, what's the area of this whole square? All of this shaded in would be 8 times 7 or 56. Okay? That's great, but we don't want the whole thing shaded in. We just want that little triangle in the middle. So what we're going to have to do is look at each corner and take off these corner triangles. That whole thing filled in was the square, but if I take off that triangle and this triangle and this triangle, then I will have just that white triangle left. This whole square was 56, so that white triangle is going to be a lot smaller than 56. So let's see what we got here. Alright, so starting with the orange, it's a triangle, and it's lined up. That's the great thing. Base times height, that may be too light. Base times height divided by 2. Next triangle, the blue. Base times height divided by 2. Green triangle, base times height divided by 2. Now, each one of these gets subtracted. I know I put a little dot there, but those are supposed to be subtracted. So let's go back to the orange. Count them. We got 8 on the side all the way down, but let's just count just the top. That's 6 on the top of that orange triangle. So that'll be 8 times 6 divided by 2, 48 divided by 2 is 24. Right? Blue triangle, little bitty one. 1 by 1, 2, 3, 4. Go all the way down to V. So 1 times 4 divided by 2. So 4. 1 times 4. And so that gives you 4 divided by 2 is 2. Alright, minus, finally the green one. We got 1, 2, 3, 4 going down and 7 going across. So that'll be 7 times 4 divided by 2. The base times the height divided by 2 each time. That's 28, half that's 14. So, in your calculator, one more time, 56 minus 24 minus 2 minus 14 leaves you 16 for the area of that white triangle that's left in the middle. When you take away the colored ones, the white one's going to be what's left. Don't forget, you have to start with the square. Alright, remember, this was the alternative, so best to do it the other way. Alright, so find expression for the area of a triangle. Kind of advanced one here. How would we set up area of a triangle? It would be base times height divided by 2. So, what's the base? 10x minus 2. Parentheses. That's one number. Times the height, 4x. All divided by 2. Okay? That's set up, but it's not simplified. And you're going to need to simplify. So, let's do a little multiplying. What's happening right here? Distributive property. Go ahead and distribute, or even better, let's go ahead and get rid of this 2 on the bottom. When you got a fraction, if you can divide it out, you're good. This is multiplying this number times this number, right? This is one number, this is one number. Even though it's parentheses, it's one number. Alright, so the 2, since that's multiplying, the 2 can go into one of them. Doesn't have to go into both. So if you divide 2, you're going to end up with 2. The x is still there, so 2x is still up there. So now we can forget about the 2, we'll forget about the 4. It's this times that. So distribute 2x times both terms. You've got to remember to do both. 2x times 10x, 2x times 10, that's 20, and x times x is x squared. That's some basic math. Negative 2 times that, negative 4x. The x is going with it, 2x is what was left up there. 2x times both. That's your simplified answer. Alright, this one, a lot of people end up missing this, but it's really a pretty simple problem if you'll just think about what I'm showing you here and how to figure out where, what the size of this is. You can do it with a little math, but you don't need to do that much math if you just kind of focus on the parts I'm showing you. I want to know a base and I want to know a height. That's where it would be, the base and the height right there. But I don't have just a plain number, but I kind of do. Going sideways, how far is this coming sideways to get to C? 7. That's your X number, right? Sideways. How far is it coming sideways to get to B? Negative 5. It's coming back 5, but it's still 5 places back. So the 5 spaces and the 7 spaces make the bottom 12 spaces all the way across the bottom. So my base is 12. Alright, my height going up. Alright, a little trickier on the height. Not as obvious to people because it gets all kind of crammed in there. The height actually starts here and goes up and then comes here and goes down. So it's 2 pieces again. You have to think of it that way. From the center, how far is it going up? That's the Y part. Up is Y, right? So it went up 4 to get to A. How far down is it coming to get to B and C? Because it doesn't matter which one. Look at them, they're both the same. Negative 6. So it's down 6. Now I don't need the negative, I'm just knowing that 6 spaces going down. So my total height is now 10. It went up 4, down 6, but that's 10 spaces altogether. Put it all over 2, and you end up with 60. The area, base times height divided by 2. 60 square units. Alright. Parallelogram's area is doubled. What happens to the base and or height? Just kind of a basic knowledge question. You don't even need a drawing. If you double the area, does it double? It's base times height, it's the formula. Does it double both of them? Does it just double one particular one? And you remember we looked at these? And if you wanted to double the area, you would only double one. It doesn't matter which one. Let's say we had an area, it was base times height, 2 times 4, that gives us 8. So what if I wanted it to be 16? Am I going to double one or two of them? If I double both, look here, double the 2, that gives me 4. Double that, give me 8. 4 times 8 is 16? No. You only double one of them. 4 times 4. That works. Or, if I double the 4, I get 8, leave the 2 alone. Okay, just double one, not both of them. Alright. Then compute the area of a regular pentagon. There's your weird formula. Apothem, area equals the apothem times the perimeter all over 2. So you can draw it if you need to. Okay, a little pentagon, that's the 5 sides. Hopefully remember that from last chapter. Each side is 10 and the apothem is 8. So a little straight up and down piece there. You don't have to draw. The apothem is 8. That's, you know, that's the 8, that's the apothem. So 8 goes there. But the perimeter is based on how many sides. Pentagon has 5 sides. So 10, 10, 10, 5, 10 times 5 gives me 50. And put all that over 2. And you end up with 200. Okay? Know your sides. You can just say for perimeter, 10 times 5, save you a little step. Or add up all the sides if you want. Apothem times perimeter divided by 2. Don't just put 8 times 10. You won't get it. Alright. Tricky one here. Be careful with this one. This is a 6 up top. 15, 12. I think I want to change this to a different number because people get a little confused on what's going on. Let me change that. Instead of being 6 up top, I'm going to change that 6 to a 4. And I'm going to change this 7 to a 9. So do that on yours. 9 and 4 changed up. Alright, so here we go. Let's see. Perimeter. Got to add up all the sides. So 15, 12, we're missing a piece. Slant. The slant piece is missing. So here's what we're going to do. We see, hey, remember this is a right triangle. We could cut that. Well, we got to know what the other side's going to be there. We don't have 12. If we cut it, it's not going to be 12 anymore. The 4 up at the top would match 4 down here at the bottom. And so the rest of this needs to be 8. 12 minus 4 give me 8. Little piece plus little piece. Segment addition possible. Alright, same thing with the 15 and the 9. The whole thing's 15. The little piece is 9. What's this other little piece going to be? 6. So now I've got 6 and 8 and x. That's a little side problem I'm going to have to come over here and do. 6, 8, and x. Pythagorean theorem. 6 squared plus 8 squared equals my x squared. And that works out to be 10. So now all I got to do is add up my numbers. 4, 15, 12. The whole bottom. Don't worry about those little pieces. The new piece is x is 10 and 9. Add all that up. Since I changed my numbers, I'm going to add it. 4, 15, 12, 15, 9, 50. Works out to 50. And that may have been, no, that was different. Yeah, that's what it was before. The same perimeter with the different numbers. So the perimeter was 50. All right, so now to find the area, you're kind of going to use a little bit of the same stuff, but not exact. So let me clean this off. We are going to split it because you can't, there's no boot shape formula. You got to split it into a rectangle and a triangle, and we had already done part of that. So this was 6 and this was 8. So now what did we cut into? The 12. Ignore the 12. And this is still 4, this is still 9. We're going to use those numbers. So now let's take the rectangle. Just the rectangle has a 4 at the top and a 15 for that whole side. 4 times 15, that's 60. On the little triangle, all you need are your base, 8, and height, 6. But what formula does a triangle have? Base times height divided by 2. Oh yeah, that's what people end up forgetting on this problem. They remember about, oh yeah, base times height, that's easy right there. But they forget that this one needs divided by 2, so take your time with it. 6 times 8 divided by 2 makes 24. So the total here, add up 60 and 24, you get 84 for your total area. Be careful with that one. Same drawing, new numbers. Alright, here's an easy one. Find the area of BCEF. Alright, go look at it and make sure you know what you're looking at. BCEF, that is a trapezoid. So, trapezoid formula, base plus base times the height divided by 2. My parallel bases, 8 and 12. My height, hitting that 8 right angle, don't forget, is 10. It's already on there. All divided by 2. We didn't use the 4. That's just in there to throw you off. So, works out to, I don't have it on my paper, maybe 100? I think that's what it is. Alright, yeah, it is 100. Or is it 50? Yeah, it's 100. 100. Okay? Alright, and then the length of a rectangle is twice the width. They love these on the ACT. Alright, let's draw a rectangle. We got the length is twice the width. Alright, remember how we used to write out little equations, like an equation for one sentence? The length, what's the is mean? Equals twice the width. L equals 2W. Alright, the area of it is 128. Area 128. So, normally you have a length. Let's put width there and length. Alright, but the length, we can't do 2 different variables, so we're going to use one to replace. L can be replaced by a 2W. 2W is just as good as writing L. So instead of writing L, we're going to write 2W. So now we're ready. We've got our 2 numbers. It's not perimeter, not adding. Okay, that's a W. Clean it up. We are doing area. Area is 128. How do you get area? Length, 2W times width. Length times width. The length is that big. Alright, so that's going to be worked out 2 times W squared. What do you work out first? That 2. Get rid of that regular old 2. Divide it out. Divide it out. That's going to end up being 64 equals W squared. And that's the easy one. Square root, the width ends up being 8. Okay? But, what did they ask us to find? The perimeter. What a pain. Okay, so let's go plug it in. If W is 8, then what's 2 times W? 16. So we got 8 and 8, 16 and 16. So, 1, 2, 3, 4, 5, 6, 8. That's 48 for your total. That's your final answer. Or add up all your pieces. 16, 16, 8, and 8. Alright. And that's it. Good luck. Yay.